What's up guys, PC here, and today we're diving into something that sounds straight out of science fiction, but which is actually very real. That is that Microsoft just introduced Marijuana 1. Majorana 1. I don't know how to pronounce it, which is a groundbreaking leap in quantum computing that could change everything. So let's break it down. Imagine a computer that can accurately model the laws of nature, solving problems that today's most powerful supercomputers can't even touch. And that's the promise of quantum computing. But until now, there have been major limitations. Now, quantum computing has always struggled with scale, reliability, and error correction. But Microsoft claims that they've made a breakthrough, one that could allow them to build a quantum processor that scales to millions of qubits on a single chip. And it all starts with a subatomic particle that was only theorized until now. The Majorana particle not only Microsoft has observed it, but they've also controlled it, leading it to a creation of an entirely new material and a brand new quantum computing architecture. So, why does it matter? Over the years, scientists have run into problems that no classical computer can solve, problems involving a behavior of even 30 to 50 electrons. Just to put that into perspective, a laptop can simulate 10 electrons, a supercomputer can handle 20, but anything beyond that is practically impossible with current technology. That's where quantum computing comes in. A properly scaled quantum computer doesn't just estimate solutions, it solves them exactly, and the implications are massive. Quantum computing can revolutionize fields like medicine, material science, and AI, allowing us to create entirely new chemicals, drugs, and materials with pinpoint accuracy without trial and error. Okay, now let's talk about qubits, which is the building blocks of quantum computing. Now, at the heart of quantum computing are qubits, the quantum equivalent of classical bits, but qubits are fragile and highly susceptible to noise, which has slowed down progress in quantum research. Now, that's where Microsoft's new breakthrough comes in. Instead of traditional qubits, they built something called a topological qubit, based on Majorana particles. Now, these qubits are more stable, resistant to noise, and scalable, and that's a major game changer. Okay, now it's important to understand the topological state. Now, we're all familiar with the basic states of matter, solid, liquids, and gas. But what if we could engineer new states of matter? 100 years ago, mathematicians theorized the topological state of matter, and scientists have been hunting for a very specific particle within it. The Majorana particle, Microsoft not only found it, but they've used it to build a new type of semiconductor called a topoconductor. This functions as both a semiconductor and a superconductor, and it's the foundation of their new quantum chip. With this material, Microsoft has created a topological core, allowing them to scale not just to tens or hundreds of qubits, but to millions of qubits on a single chip. And all of this fits in the palm of your hand. Alright, now let's talk about how the Majorana 1 chip actually works. Now, unlike traditional chips, they rely on electrons for computation. Majorana 1 uses Majorana particles. These are half electrons that allow for error-resistant quantum states, making the system highly stable. Each atom in its chip is placed purposefully, essentially painting a picture atom by atom. The result, a chip that can store over 1 million qubits and process them at an unprecedented speed. The quantum classic hybrid, Microsoft's approach isn't just about pure quantum power, it's a hybrid system. The Majorana 1 chip works alongside classical computing hardware, optimizing between classical and quantum processing depending on the problem at hand. Once the quantum accelerator completes a calculation, the classical system processes the result, delivering a final result with unmatched accuracy. So what can you do with 1 million qubits? Well, we're entering an era where quantum computing could enhance artificial intelligence, revolutionize drug discovery, and even help design new materials at an atomic level. Imagine being able to simulate the exact properties of material before even stepping into a lab. Imagine batteries that never need recharging, or AI models that can make breakthroughs in seconds instead of years. Now, Microsoft has been working on this for 17 years, and they're not saying that this is real, this is happening. We're literally standing on the edge of the quantum age, and Majorana 1 is just the beginning. So, yeah, that is going to be it for today, and thank you for watching. I'm going to catch you tomorrow, if we survive this quantum age, of course.